think about, this is a derivative. Who was his original? Now, up to this point, how would you have to solve this?
FOIL.
Okay, go, FOIL. Find me an integral. Show off and say, Psh, if you gave that to me on the test yesterday, I would have aced it. Go.
Oh, man.
Sounds like a healthy brain food.
For a long time, I've been calling almonds legumes, because like, that's what I thought they were classified as. And then I realized that legumes are beans and such, and that's a nut.
Well, it isn't a common category, but
I was in ignorance, and
now you're enlightened.
yes.
It's a good day. Oh, man. But I think you would have probably said before that you knew those were nuts.
I thought nuts and legumes were synonymous.
Yeah. So you knew what nuts were, you just didn't know what legumes was.
Yeah.
Yeah.
I still call them legumes though, because it's funny to me.
All right, I'm zooming in because you guys should be done, right?
No.
Oh, come on.
Calc chat.
Don't do that. That's what pre-cal does. Come on, we're better than that. I'm just going to pull the 10 out because I don't want to have to do hard math.
Oh. I should have done. Oh, well.
Steve, can you pull out a 10x?
No. Why not? Why can't I just pull out the x?
Because you can't do it that way.
Yeah, I can't pull out a variable because that'd be me starting to solve. I can pull out a constant because that's totally allowed, right? But I can't pull out an x because that's like me starting to say, hey, part of my answer has an x in it. I can't do that. I have to anti-derive. Goodness gracious. Oh, you guys, I'm fine. Well, that was pretty sad when I came back on Wednesday. They're like, you sounded like you were dying. Oh.
You're done?
No, because I take lessons for the other classes on Tuesday.
Okay.
And I guess I sounded really bad in the videos or something. I don't know. I'm better. How pretty is that answer?
Not really.
It's not. And here's the problem. That would not have been a multiple choice answer.
Oh, no.
Nothing close to it would have been a multiple choice answer. The multiple choice answer would have instead been
I don't know how they got that.
No.
So I'm just gonna stick it to them.
so if they're both right, is our old method gonna work very well anymore? If they're both right, and if the multiple choice would have the one on the right, our old method isn't gonna cut it. And that's actually a good thing because we're gonna totally expand our horizons as to what we can solve and what we can integrate. Can anybody see why the answer is what I boxed?
No.
Uh-huh. If you were to take the derivative, right? The answer to an integral should be able to be derived back into the integrand, right?
Right.
So how do I take the derivative?
Chain rule.
I could cube it and then take little baby power rules, and I would end up with, well, probably something like this. Or I could do chain rule and say, psh, bring down the, and that cancels. Now it's a 2, but I would also have a
Prime.
u prime.
Yeah.
Wait, so the 10x is really just the u
U prime?
prime?
Oh, yeah.
And then the derivative of c is 0, so he's not there anyway.
Whoa.
This is what we're going to start talking about.
My mind is
How do we
blown.
deal with chain rule inside integrals? Can I make this bigger? Hold on. Well, that didn't help. Hold on.
For integration.
is zoomed in and then zoomed out. Here we go. So here's the idea. What we used to be restricted by, which is still kind of a restriction, there is no product rule for integration. So those different AP things I had you say, no, the product doesn't work. You're totally right, the product doesn't work. But there are going to be some more special products besides secant tangent, besides, yeah, you can switch it out, Kevin. Besides secant tangent, besides cosecant cotangent. Are there any other special products? Not right now. Drill. Right. We're going to have new techniques. We're thinking of chain rule. So if every derivative rule can be made into an integration rule backwards, if every derivative rule can be made into an integration rule, then I can take chain rule and make it into an integration rule. Where I can look at integrals a new way, especially complicated ones, that doesn't mean imaginary, complicated ones. And I can be looking for u primes. Now we're going to have a strategy, we're going to have a system. And there are many different systems that I could show you. And if you go to BCers this year, they would have even a different system than I'm going to show you this year. So last year was a little bit different, and the way I naturally do it is a little bit different. But I've seen a new system recently that I think eliminates some of the creativity that my old system needed, which for some of you is a good thing. You don't want creativity in math, so I'm trying to kind of eliminate it. Some of you will be able to shorten the process a little bit, but we're all going to follow the system originally until we get it down. Are we almost down to the blue stuff? I'm going to zoom in again. I want to come back to the original example, and I want to do it a different way besides foiling. I want to do it a different way besides foiling that ends in that nice multiple choice answer that would have been there. If I look at this, and if I say, that's awkward. There's a product. I always do that. Undo. And I think there might be like a hidden u prime in here. What we're going to do is, before we even start worrying about the u prime, identify u, which is what we did with derivatives anyway. We would look on the inside and we'd say, hey, there's something complicated. Let's figure out what u is. Take the derivative of the outside, keep the inside times u prime. But now we're trying to kind of analyze this integral and say, all right, I think there's a u in there, and the du is going to be there as well, or the u prime, so I kind of have to figure this out. If we look in here, you guys have been looking for u's before, it's just been a while. Hopefully your eye would naturally go to the innermost, right? And the innermost would be 5x squared. And if there was a u that was inside a function, then this derivative, the integrand, which was a result of a derivative, should have a u prime. So without even really considering this too much, I'm going to find u prime. Now wait a minute, why am I writing du dx? Doesn't that?
U prime.
Yeah, it's the derivative of u with respect to x. It is u prime. I'm just doing a different notation. You'll see why in a second. And if I look at my u prime would be 10x and the way that we're going to use this u, what we're going to call it u substitution, that's what we're going to call it on the next page. We're going to use u substitution to take this integral, which right now doesn't fit any rule, and we're going to try and simplify what is really here. Simplify what all of this mess looks like. So I'm going to go ahead and say, all right, right now, can I substitute this for u? Could I technically? Yes. However, I'm also going to have 10x, and I'm also going to have dx. Now, guys, in this example, 10x is the perfect u prime, because that's exactly what u prime equals, right? But that's not always the case. So my system isn't going to be like, hey, it's always going to be this easy. My system is going to be like, sometimes it gets harder. So instead of thinking about trying to plug perfectly in for whatever that extra piece is, instead we're going to look to substitute for the u, and then we're going to look to substitute for the dx. Because if we get u's, we have to have a du or else we can't take an integral. So I'm going to go ahead and solve for the dx next. Dx is equal to du over 10x. I'm trying to change an integral in terms of x's to an integral in terms of u's, and then I can see what was, I can see the derivative a little bit clearer. Let me show you what I mean. So now when I go ahead and plug in, trying to get everything in terms of u's, I can say the integral of u squared times 10x. This is kind of like a transition step because it's not perfectly in terms of u yet, but hopefully soon it will be. I can look at my original integral as just being the integral of u squared du, which in that case it's like, psh, got this, power rule. It's going to end up being u cubed over 3 plus c. I need to go back to my original terms, which is what u really stands for, which would be 5x squared plus 1 divided by 3 is like times 1/3 plus c. Done. Emily.
Is it u squared just because the original u squared, or is that like a thing that we would?
Oh, I'm literally just plugging in.
Okay.
So I'm starting here and I'm saying, hey, I made you u, ta-da, and you were squared, ta-da.
Okay.
See what I mean? And then I just left the 10x and then dx, I went ahead and said, what are you? Plug it in, simplifies down, and go. Jenny.
There to be cubed.
Oh, cube, thank you. I was too focused on how ugly my 3 was. I know, sorry. I was too lazy to erase it. Let's go ahead and write down some steps as to what I just did. U sub lets us take functions that don't just have x. They have something else. U sub lets us deal with integrals with arguments that are not just x. So some of the ones in AP, what was it, 10? Where I said wait, you could have been able to do if you knew U sub. Some of the ones in the test review that I said you might not know how to do by hand yet, you needed U sub. You were close. Not quite. Oh, Haley, you need these too, huh? And at the very, very bottom, if it's an indefinite integral, don't forget your
Let's see.
plus c. Did anybody forget that yesterday? Kill it. Every indefinite plus c. Unless they give you a point, then you need plus c, then you solve for plus c, right? Is there so quiet? Oh, what am I doing? Soccer's gone. So what you just saw me do was look at the integral and say, what would you have been? Choose wisely, sometimes you'll be wrong. Wait, you can be wrong when you choose u? Yeah. Sometimes you'll be wrong. Probably not at the beginning, but as we go on. Find du, and more specifically, since I'm doing a little bit different of a system, du dx. So I'm going to add a little bit. Solving for dx. just means find u prime. Rewrite the integral in terms of u. Start plugging in. It might not be totally u's at first, but then hopefully when you simplify, you'll have a function of u's, or in terms of u's, and then du. At which point you can then just say, sweet antiderivative in terms of u, plug in terms of x's, and then never, never, never forget plus c. Plus c. You ready for an example?
Yay.
Ready to bust it out? Any marks? Get set. Benji might have to skip space. Oh, you just circled?
I'm good.
You're there. Go. These are the easy ones still.
That would make me confident.
No, this is when u prime is fitting exactly.
Prime fits exactly.
I know some of you will want to make shortcuts for the process. Just be super, super careful. We're on the easy ones. The system has purpose. And it might not seem the most efficient way to do the easy ones, but it will simplify the process for harder ones. There's no place do I have. Did I look at the backboard? I don't remember. Guys, it's the weekend, WCC. Homework 35 is the homework on use of section 6.3. Due on Tuesday, but you should have, I would say, at least half of it done for Monday. Especially for some of you, since we're starting on a new chapter, we can start off on a clean slate. And we can say, okay, I'm gonna resolve to start homework when we're starting the section. Write it down in my calendar so I don't forget. And then it won't be near as bad at the end. Yeah.
So would you just be like first?
What would you be? Not the first. Not the first. What do we always think about? You as the innermost. Right?
Okay.
I'm catching up. Well, that worked nicely. Does that make sense?
Oh, okay.
Does that make sense? Because all I'm doing is a plug-in. I'm trying to get into terms of u, so I can get my innermost argument in terms of u. I can get my dx in terms of u. And then I'm hoping he was just a result of, ooh yeah, the u prime. And he was. So now it's just, guys, integral of u to the 1/2. 2/3, u to the
3 over 2.
3/2. Let's see. But I need it in terms of, well, I didn't have u's to begin with, right? So what is it really? Not u. What is it? And we know they could write that with radicals and all kinds of funniness, but whatever. Answer done. Who got there before me? Nice, 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 nice. Those of you that didn't, questions? Another one. Mark set. Go. Ooh. That just got exciting. Can't always trust the cover. Maybe fun to decide something next time. Guys, what's u? Did you find it?
Tangent.
Tangent of x? Why? Why not secant? Because tangent's cubed. That's not a good enough reason, but maybe it would have been a hint. What is du dx of tangent? Yeah, you know what? Just say it louder. Secant squared. There we go. Is it starting to make sense as to why we pick what we pick? Because it's a product. And I don't have a rule for secant squared tangent cubed. I have a rule for secant tangent. Maybe it wasn't a perfect rule. Maybe there was a u that was being cubed, and then there was a du. Well, he wouldn't have been cubed, huh? Hold on. We're talking too much. We should be solving. If u is tangent, that's just like a power that u is being raised to. U prime is secant squared. So then I have dx is equal to du over secant squared of x. Then I can go u cubed. Plug in dx. Hopefully, if all goes well, which some of you see earlier than others. Yep. We can think about it just as u cubed du, which then of course has the antiderivative of u to the fourth over 4 or times 1/4 plus c, but I don't leave it with u because what is u truly? Tangent. So 1/4 tangent. We have that cool notation for powers of trig to the 4th plus c. Cool?
Where did you come from again?
The u came from my asking and people telling. People could have tried secant instead, but secant has a du dx of secant tangent, and then we would have had too many tangents. It wouldn't have all canceled out. So part of it is a strategy of seeing tangent secant with powers isn't one of my rules. Tangent secant alone is one of my rules, but not tangent cube secant squared. So I couldn't just use a rule. Then we were looking and saying maybe there's some u sub I should do. Maybe this is the result of a chain rule. So then u, we look in the innermost, but it's like, well, they're about the same, right? So the strategy is pick a u whose du, either partially or completely, is there. So then it worked out nicely since we chose u to be tangent. Then secant squared was part of the u prime. Then when I went to go change it in terms of u, I saw it truly was just the u prime, and so then I could just think about it as u cubed. So then looking down here, bring down the 4, make it a 3, times u prime. And if you had chosen u to be the other one, it wouldn't have worked out. I would have still had stuff in terms of x's. Let's actually look at that. What happens if you do choose the wrong one? You guys don't have to get your pens going on this one. Pencils, you shouldn't be writing in pen, math class. What if we had chosen, I just want to show you what it looks like because we are going to have harder ones in just a second. What if you had said u equals secant? Because you're like, I don't know, they're both the powers, right? Then du dx would have been, what is du dx, guys? Secant tangent. So then dx would have equaled du over, you're like, whatever, maybe stuff cancels out. So then you go to start plugging in, and you say, okay, I have the integral of tangent cubed of x times u squared times, plug in dx, du over secant x tangent x, well, one of those cancels. I can't solve it because it's not all in terms of u, so I'm stuck now. Doesn't mean, what could we do? Tangent squared is 1 minus secant squared, so then I could have done 1 over secant minus secant squared over, but either way, I would have had x's and u's, and that's an impossible integral because it's not all in terms of one variable. Does that make sense? So that's why it's like, ruh-roh, and then we say, that's not the right one, so then we try something new. And there's definitely going to be times when you choose the wrong one. It's just a part of you said. Okay, what do we do if, go. I changed it up just a little bit. It's going to be a little off, but maybe you won't even realize, because if you follow the system, you should totally get to the right answer. It's just going to be a little bit different. Can you text Nikki and tell her I have reimbursement money for her? Or just tell her. How'd it go? Did the system work? Even though it wasn't perfect? Because as long as we solve for dy, well, dy is there, right? So we're just going to plug in for whatever dy is. So we plug in the du over 4y. The y's cancel, the 4 doesn't. Whatever, big deal. Off by a constant. I just pulled them out. And then he was there in my answer, and I'm done. Any questions on this one? I'll give you one more of these until we get to really exciting ones. What if you're off by a variable? Question, if it was like a y, can I pull a y out the same way I can pull a 4 out? Ooh, that's going to be a dilemma.
No, just give me that one.
What do you guys want? Trigger square
I
root.
like 4. I like number 4.
This
It
one?
looks
No.
nice. No.
Yeah, that one is kind of easier. All right, let's do this one. Although, I'm just going to switch it up. Let's make it. Ha.
What did you do?
done? Positive 1/2, even though my test review told you that I thought it was something different. Maybe you got that, maybe you didn't. I did the same thing I did in period 1. It's minus.
Oh,
I don't know why. I don't know why. I have no idea. Why 2? That's what I heard someone. Uh-oh.
well, when you.
Cass, what's wrong?
Why isn't your final answer like squidward?
Because I got focused on my +1.
Where'd you get 2?
Where did I get 2? Well, Benji, I have to add 1, right? So +1 is
Yeah,
1/2 divided by 1/2 is times 2/1. You just don't see the fraction as clearly, but it's still there. And then 3/8 times 2/1, the 2 and the 8 reduces. Now I got it. Cool?
Cool.
How about?
No.
Try this one. Try to use your system and see what you think. Life just got a little more exciting. Just start the system. Just start the system. You might be thinking of, wait a minute. Start the system, see where you go. Try the system, what happens this time? Is there something you could do? Look at all that you have in black. We're trying to get it in terms of you. Is there a way? Thanks. The integration is we aren't. Okay, so. Just for 7 years. I think I called it crazy integration at first, and then my first year was like making fun of it. What'd you guys get?
4, I don't know.
What happened? I'm starting.
U equals x minus 1, that's all I got. 1.
Uh-oh. Is that another impossible one?
Yeah. No. Yeah. No. Yeah.
Okay, everybody. We want to get it in terms of you. Any ideas? Substitute what?
Oh. Wait, what?
We had more resources than you realized. wait a minute, it's still a product. So that didn't really help anything?
Do it again.
No.
Do it again.
Because now it's possible, whereas before it was impossible, but why? Why is it possible now?
We can do it again.
I can FOIL and I can bring in, because the square root is with you, not the square root of x minus 1. What? Hold on. I can FOIL, I can distribute, and I can solve this puppy, whereas before I couldn't. So now I have u squared plus 2u plus 1, wait for it, hold on, u to the 1/2 du. Is this possible?
Yeah.
U to the, not 3/2, u to the 5/2 plus 2u to the 3/2 plus, wait, it's a 1, I know, foiling the struggle, plus u to the 1/2. Kiddos, can I do it?
Yeah.
Yes, I can. Information on crack. Get out of here. I will see you. Homework due on Tuesday. WCC is a weekend. Oh no.
What?
Running.
You gotta stop it. You gotta stop it.
Hold on, let me get antibacterial.
Don't you get the ride. Oh, you got it. Bye, Jimmy. My buddy, Jimmy, my buddy.
Yeah, I know that. What do you want?
You weren't?
Did he leave it?
Nasty, selfish, disgusting animal.
Wow. Can I turn in my homework packet like